Hey everyone, hope you're doing well. In this video, let's go ahead and take a look at this system of equations given 3 variables. If you'd like to try this problem on your own first, go ahead and pause the video and do so, and then when you're ready to go over it together, just unpause it and let's give it a go. First, just to keep things nice and organized, I'm going to call this first equation, equation A, the second equation, equation B, and the third equation, equation C. So right now we have 3 different equations with 3 different variables. The way I'm going to go about solving this problem, solving the system rather, is that I'm going to go ahead and see if we can create a system with 2 equations and 2 variables and go from there. If you're working on trying to understand how to solve these systems with 3 variables, I'm assuming you've already tried doing them with 2 variables first. To create 2 new equations with only 2 variables instead of 3, I'm going to use the elimination method. Using equations A and C, I'm going to multiply the entire equation C by 2 and then add it to equation A. Let me show you why we're going to do this. So here's equation C, and let's multiply the entire thing by 2 or distribute 2 to each term of the equation. When we do so, we end up with 12x minus 2y plus 8z equals negative 2. Let's go ahead and take a look at this new version of equation C and compare it side by side with equation A. By multiplying equation C by 2, notice how the coefficients for the y terms are opposites. If we add these 2 equations together, these y terms are going to be eliminated. 12x plus 4x equals 16x, the y's get eliminated, 8z plus 3z equals 11z, and negative 2 plus 1 equals negative 1. Now we have an equation with 2 variables. Let's go ahead and call this equation D. And just to keep things organized, I'm going to move this to the top and we're going to use it in a little bit. So now we have this new equation D that only has 2 variables, x and z, and we're going to try to create another equation that looks like this that only has x and z. So just a moment ago, to create equation D, we used a combination of equation A and C. This time, to create another equation, I'm going to use a combination of equations B and C. To create this next equation with only 2 variables of x and z, let's go ahead and multiply equation C by 3 and then subtract equation B. So here's equation C, and let's go ahead and multiply 3 by every term of this equation. We'll multiply 3 by 6x, and the negative y, and the 4z, and the negative 3. By doing so, we're going to get 18x minus 3y plus 12z is equal to negative 3. If we take this new version of equation C and compare it side by side with equation B, we can go ahead and notice that the coefficients for the y terms, or these negative 3's, match. To eliminate these negative 3's, we're going to go ahead and subtract these equations from each other because negative 3 minus negative 3 equals 0 and the y terms would be eliminated. 18x minus 2x is going to be equal to 16x. These y terms are going to be eliminated. 12z minus 5z is going to equal 7z, and negative 3 take away negative 14 is going to equal positive 11. Let's go ahead and call this equation E. Just to keep things nice and organized, let's go ahead and move this equation E next to equation D in the top right. So let's review what we've done so far. We started off with 3 equations, equation A, B, and C, and they all had 3 variables. We just used the elimination method, or the strategy, and we came up with these equations of D and E. Equations D and E only have 2 variables instead of 3, and this is much easier to solve now. Lucky for us, in this particular example, the coefficients for the x terms already match. They both have a 16. That being said, we can easily eliminate the x terms and then just solve for z. To do so, I'm going to go ahead and subtract equation E from equation D. By subtracting 16x from 16x, the x terms will be eliminated. 11z minus 7z is going to equal 4z, and negative 1 minus 11 is going to equal negative 12. If we go ahead and divide both sides by 4, we find out that z is equal to negative 3. At this point, we now know that z is equal to negative 3, and we're going to try to use this information to help us find out the other 2 variables of x and y. Now that we know that z is equal to negative 3, let's substitute it into equation E or D, where the z variable is. Now it's totally up to you which one you want to substitute it into, but I'm going to choose equation E. Substituting in, we get 16x plus 7 times negative 3 is equal to 11. Then simplifying this, we can get 16x minus 21 is equal to 11. Go ahead and add 21 to both sides, and we get that 16x is going to be equal to 32. And then finally, we can divide both sides by 16 and find out that x is equal to 2. So first we found out that z is equal to negative 3, and now we know that x equals positive 2, so let's use this information to help us find out the value of y. To solve for y, let's take the fact that z is equal to negative 3 and plug it into one of the spots for z in equations A, B, and C, and do the same thing for the fact that x is equal to positive 2 into x into the original equations of a, b, and c. Again, it's totally up to you which equation you want to use, but for me, I'm going to choose equation a. And if you feel like using equations b or c instead, go ahead, you do you. Substituting into equation a, we're going to get 4 times 2 plus 2y plus 3 times negative 3 is equal to 1. Simplifying this a bit, we're going to get 8 plus 2y minus 9 is equal to 1. Combining the 8 and negative 9, we're going to get 2y minus 1 is equal to 1, and adding 1 to both sides of the equation, we're going to get that 2y is equal to 2. And finally, dividing both sides by 2, we find out that y is equal to 1. Now that we know the values of x, y, and z, we can write our solution as 2, 1, negative 3. And if you want to double and triple check to make sure that this solution is correct, you can go ahead and plug these values into equation b and c and see so for yourself. Hopefully you found this video helpful, and as always, keep up the great work, and I'll see you in the next one.